so I'm going to go through number 49. And looking at 49, there's just a bunch of chaos in these tables. And I want to get rid of the chaos and pare it down to some simple sign charts. Okay, so for the first one, I'm going to make a sign chart for f prime and f. All right, now, this information is really helpful. It says f is continuous on the interval from 0 to 3, so I'm only graphing it from 0 to 3. I like to cap my sign charts when it only exists for finite values because it's helpful for me to organize my information. So I'm going to do an f prime f sign chart. I'm going to do an f double prime f sign chart. And they're both going to go just from 0 to 3. Okay, so for f prime f, I want to look first for critical points for f prime. And f has a critical point. I shouldn't have said that way. I don't want critical points for f prime, I want critical points for f. So critical points for f are where f prime is 0 or does not exist. So looking at this chart, this is where f prime is. And I have a value of 3, which I don't really care about. The only thing I care about from that 3 is that it's a positive number. I have a value of 0, that's a critical point. It's when x is 1, f prime is 0. Okay? And then when x is 2, f prime doesn't exist. Okay? F prime being -3, I don't really care about. When we're talking about these f prime values, we're talking about whether f prime is positive or negative, or not, or 0 or does not exist. We're not talking about specific, a 3, a -5, a half, none of that. So that's all I'm going to take there, okay? And really, from that top sign chart, that's all or that top graph there, table, that's all I'm taking. For the second table, I'm going to look into the signs of f prime. So f prime is from 0 to 1, that's this interval, f prime is positive. From 1 to 2, f prime is negative. And from 2 to 3, f prime is negative. Okay, what does that tell me about my function f? Well, when f prime is positive, f is increasing. And when f prime is negative, f is decreasing. Okay, when f prime is 0, I should have a horizontal tangent. And when f prime doesn't exist, I should have funny business. I'm not going to concern myself with that right now because if I do this properly, they should take care of themselves. For my second sign chart, I'm going to go back to the first table. F double prime is 0 at 0 and at 3. All right, that's interesting. At x equals 1, that's not an important point for f double prime. It has a negative value. I don't want to put that on my sign chart because it's not an important point. The x equals 2 is because the second derivative doesn't exist there. Okay, and that also makes sense because if the first derivative doesn't exist, the second derivative can't exist. Okay, but we don't want to put anything extra on our sign charts because it'll lead us astray. Now I'm going to move to my second table where it says that f double prime goes from negative to negative. It's negative everywhere. So from 0 to 2, it's negative. And then from 2 to 3, it's negative. And when f double prime is negative, f has to be concave down. Okay? I'm now going to draw my axes, and I'm going to line them up with this stuff. Okay? That way everything is lined up. It makes things easier for me. Now, anytime something is changing, I want to make sure I note it on my graph. So at 0, I'm going to begin. At 1, I have a change in direction. I go from increasing to decreasing. At 2, I have a change in, well, it's saying that my derivative doesn't exist, so it's 2, something important is happening. And at 3, my graph ends, okay? If I go back to the first table, I can now look at this top line. Okay, the top line is telling me what the f values are at certain x values. Well, if I pair them with an x, that's really like a y. So these are coordinates. So I have the coordinate 0, 0. I have the coordinate 1, 2. Okay, I have the coordinate 2, 0. And I have the coordinate 3, negative 2. Okay, now I'm going to use these shapes, okay, to, hang on for 1 second. I'm recording a video. Sorry. So I'm going to use these shapes to better my graph. So I have concave up and concave down. And then I'm going to decrease here, increase here, increase here, decrease there. Okay? And now I'm just going to look at one piece at a time. So the interval from 0 to 1, that's this section here. And I'm going to graph this section here has to correspond to this and this. So 0 to 1, I'm increasing. 0 to 1, I'm concave down. Increasing concave down is supposed to look like this. Now, I know that when you guys looked at 49, you're like, holy hell, with what's going on here. But when you have those points, it's so nice. So I just have to connect this point to this point and be increasing concave concave down. So that shape right there, that shape right there. So up, increasing, concave down, okay? From 1 to 2. 1 to 2 is right here, 1 to 2 is right here. I've got to be decreasing. 1 to 2 is right here, also concave down. So decreasing, concave down, that looks like this piece right here, decreasing, concave down. So I'm going to graph that, connecting this point to this point. Do you guys see how the horizontal tangent took care of itself? Perfect. Okay, I got my horizontal tangent at 1 like I was supposed to. My next bit, from 2 to 3. 2 to 3 is right here, 2 to 3 is right here, and right here. So decreasing, concave down. That's what I just graphed. So I got to do another one of those, right here. Okay, decreasing, concave down. Do you guys see I have my funny business here? Got a corner. Derivative doesn't exist, second derivative doesn't exist. It's perfect. Okay, and that's how we got the graph for 49. 50 is real similar to that.